Hello, everybody, and welcome back to stage 3. So just some quick housekeeping. We want to thank all our sponsors. Again, those are MongoDB, Microsoft, Verizon, Salesforce, Amazon Information Security, eLearn Security, Intel, and Remediant. Today we have Amanda giving her talk. I'm very excited by this. Just quickly to introduce Amanda. Amanda makes magic by using sticks to turn fluff into stuff. She listens to complaints of computers to pay the bills. She's going to take over one quick second, and we're going to run Q&A afterwards. So I will be posting a link, but feel free to post your questions in the chat room. Please welcome Amanda.
Thank you so much, Lee. As she mentioned, I am Amanda, and I'm going to be talking to you about some lessons that I have learned from playing with string. If you looked at the title and was all excited about the command line tool strings, sorry to disappoint, this is not going to be that talk. I'm going to be talking more about string, about yarn and thread and things that you sew with and knit with and weave with. Those sorts of strings. So why in the heck am I talking about textiles and fiber arts at a security conference? Well, if you're at all familiar with the history of computing and punch cards, you know that that was a technology that was really originated for Draeger looms. So the original computer was something used to weave. And this is the same technology that you'll see in knitting machines, which are also a very binary thing, knit versus purl, or a knit stitch versus a yarn over to make a hole within the fabric. Lots of different things that you can do here. And if you look at a lot of knitting and crochet patterns, like the little snippet that you can see below, it looks a lot like machine code. That in particular is a snippet from the Even Star shawl, but many other patterns look very similar. So knowing all of this and also being a computer geek, then there's this pandemic thing that happened. And like so many other craftspeople, I started sewing cloth masks. So many masks. Some of them went to my colleagues, and some of them got sent to medical facilities and elder care facilities and schools and things all over the country, which massive shout out to US Postal Service. Current craziness notwithstanding, they do awesome work. And while I was doing all of that sewing and cutting and measuring and all of these things, I realized there's some universal truths out there that regardless of what the craft is, whether you're doing fiber arts or computer wizardry, a lot of the same concepts apply. And so I wanted to share some of the things that I learned from that. First and foremost is the importance of understanding how stuff works. Warning, there's an animation on the next slide. It's not blinky, but if moving pictures are a problem, you may want to look away from the screen for a moment. So what you're looking at here is an animation of how sewing machines work. Now, if you've ever wondered how the act of sewing, that when you're doing it by hand, is this very clearly not machine capable thing of putting an entire needle through the fabric, through the fabric, through the fabric, and so on and so forth, like how does a machine replicate that? Well, this animation answers that question. Turns out there's actually 2 threads, and the machine is able to loop one around the other, and that looping action is what holds the 2 layers of fabric together. Now, once you understand this concept, you can do a ton of troubleshooting on any issues that your sewing machine is giving you. For example, if the loops are pulling towards the top of the fabric, well, clearly the tension on that top thread is greater than the bottom thread, so you have to loosen that top tension so the bottom thread can come down, and the reverse is true. Now, all of this is material that you'll find in your sewing machine's manual, if you still have a print manual anymore. A lot of them have gone online. But point being, yes, you can look this up every single time that you have a problem with your thread tension, Or you can just understand how stuff works. When you understand how it works, you can just fix it. You don't have to go look it up every time. You understand. This is a concept that we're going to return to a lot during this talk. All right, the animation's gone now. Next, we're going to talk about automations. You're probably asking yourself, isn't the sewing machine automation enough? What other automations can I add to the sewing process? Well, you're looking at a piece of automation on the screen right now. Those little plastic bits are a really cool technological advance in sewing, or well, properly in ironing. Just think for a minute, what could those pieces of plastic be? So it gave you a little bit of a hint in talking about ironing. It turns out these pieces of plastic are a jig. If you're familiar at all with woodworking, you understand the concept of a jig. It's something that takes a really annoying process and turns it into a really easy process. For example, if you're trying to cut a piece of wood at an awkward angle, you can either measure it and hold it exactly right every single time, or you build a jig so you can make the exact same cut every single time. What this particular jig does is it handles the process of making bias tape, which is one of the things that, especially with elastic being at a premium right now, is useful for making ties for those masks. What bias tape is, you take this piece of fabric and then you iron it in half to make a crease, and then you're going to iron the edges in towards the middle and then fold it in half. So ultimately you have no raw edges on that piece of tape. But that is an exceptionally painful and annoying process. And I do mean painful literally, because as you're trying to hold things there and getting the iron there, you're probably going to steam your fingers, and it physically hurts. I do not recommend steaming your fingers. But this concept illustrates a lot of fundamental questions that you should ask as to whether you should keep doing a process manually or should you try to automate it. And the first is what is the task within a process that is physically painful? Granted, with computers, you're not usually dealing with physical pain, but there's often something about the process that is really annoying. That is where you're going to have the most return on investment for automating a process. Another question to ask is, what task within that process is where human error is especially easy and especially bad? So as I mentioned before, with that bias tape, the cost of the error and the cost of that is that you might burn your fingers, and steaming your fingers is bad. If you get close enough, you actually run the iron over your fingers. That's really, really not good. And that's also really easy to do. So, focus on where humans perform the worst. That's probably where computers are going to perform the best. So again, that's where you're going to get a really high return on investment. Another thing to consider is, what is the task that isn't going to change much? With bias tape, I can know ahead of time that all of my tape needs to be roughly the same size. And so that makes it worth making a special doohickey to handle that particular task. If on one mask I was going to have to deal with 1-inch strips of fabric, on the next one I was going to have to deal with 1/2-inch strips of fabric, on the next one 2-inch strips of fabric, that would be a ton of those little plastic things that I would need in order to deal with all that. Is it possible to do that? Sure. Is it worth it depending on how much tape I'm making? Maybe not. And all of those cost-benefit analyses also talk about, is it worth putting the work in to automate versus just throwing lots of people at it? If you look at textiles on a commercial scale, your clothing factories aren't shove a piece of fabric in one end and trousers pop out the other. It's a whole lot of humans doing processes as if they were machines. So sometimes, even with the greatest technology in the world, the answer is a lot of humans. And part of that is the changeability. How much do you need to be able to adapt? And to answer any of those questions, you have to go back to our first point, understanding how stuff works. This is important not just to decide if to automate, but once you have an automation solutions in place, you still have to understand how stuff works because, yes, anyone can run a script. However, when something fundamentally changes and that script breaks, can your people change the script or revert back to a manual process? So even when you have automations, you still have to train your people on how stuff works because things break, and you have to be able to compensate for that. Now, every once in a while, you can't automate the process. Like I was talking about before with the clothing factories, it comes down to a lot of humans. But what you can do to make things a little bit easier is batch processing. So what you see on the screen is an example of batch processing. It is where I have, instead of sewing an entire mask and then moving on to the next mask and sewing an entire mask, I have done one step of sewing a mask. That is sewing the pleats down in the middle right here. And then I did the next step, which was sewing the edges down right here. If you look really closely, you can see, especially right there, that everything is connected together. I didn't cut everything between each mask, which is cool and sped things up because I could just keep shoving masks into the sewing machine. However, in this particular example, I actually over-optimized a little bit. I over-batch processed because, while everything here was all sewn together, that meant everything got all twisted up and tangled as I was sewing these parts. And that caused me to spend a lot of time just untangling things, whereas if I would have cut in between each mask, while I would have spent time cutting between each mask, I would have saved a lot of time untangling. So, make sure that you understand that sometimes things like automations and batch processing actually slow everything down. Next lesson, to plan or not to plan. Weaving is a highly planned craft. What you see on the left-hand side is what is known as a draft. It's essentially a weaving pattern. With some graph paper, you can plot out how you have to thread everything into the loom and then how you are going to manipulate the loom in order to produce certain patterns. If you don't plan this out, you are going to get utter and complete randomness. But also, you end up with some interesting things where one draft, so this piece on the top here, one of those, but with multiple different ways of manipulating the loom, can give you 3 different patterns, which you see on the right-hand side. All 3 of those were from the exact same draft and warp, that is the yarn that you use when setting up the loom, but different manipulations to the loom and different weft yarns, the yarn that I actually use to weave with. So all the planning can give you multiple different results, but you have to understand how stuff works in order to plan that out. In contrast, crochet is not so planned. Here you can see our lovely Iron Snail Man, who you may recognize from my Twitter avatar. Now, crochet, unlike weaving, can be a very improvisational craft. Crochet allows you from one location in your pattern to go literally anywhere else on the object that you're crocheting. So, for example, the little eyes that you see. The pattern didn't tell me exactly where to put the eyes. It just said to put the eyes in a spot that looks kind of like eyes. Instead of saying to do exactly this many stitches for this many rounds in order to produce the body, it was keep going until you're at about yay many inches. So you have a lot more freedom with crochet. So when you're looking at your project, do you plan or do you not plan? Are you building the equivalent of network duct tape, just get it fixed quickly? Or are you building something that's meant to last? Are you building something that needs robust documentation? Are you building something where you need to carefully consider what programming language or what framework you're using to build that project? Or do you just need it to work? In order to answer those questions, you have to understand how stuff works, how that project supports your particular business environment and your company's priorities. Next lesson, tools don't matter, except for when they do. On the left, you can see what is essentially the height of spinning technology for the home spinner. It's an electric spinning wheel. It has a motor and a battery, and you can plug it into the wall or your car, and it has a foot pedal and speed controls and a tension knob. And it is really cool. I'm not going to lie, I absolutely love it. On the right-hand side, you can see a supported spindle, which essentially is a stick. Now, clearly, the electric spinner is the superior tool, except it's not. It does have cool capabilities, but what if I want to spin for 10 hours and I'm not going to be anywhere near a power outlet? Well, that battery is going to run out after maybe 2 hours tops. Maybe I want to carry my spinning around with me in a light bag. That electric spinner with its battery is not something I want to toss in my purse, whereas that stick absolutely is. Maybe I don't want to fiddle with a whole bunch of settings. Maybe I want to literally walk around while I'm spinning. This is a very similar type of spindle, except whereas the one in the picture there is meant to be U supported, this one has a little hook, so I can literally spin while I'm walking around. The lightest spinning wheel in the world is not going to be that flexible of a tool. So sometimes the right tool for your job is a giant tool suite. Sometimes it's a tiny command line script that does one thing extremely well. And don't neglect tools that only make things easier. For example, you can see a picture of a wrist-mounted pin cushion. While the pin cushion doesn't directly lend itself to sewing or ironing or any of those tasks, just not having to chase down a pin cushion that might have rolled away made sewing at scale so much easier. And as you're deciding what tool's right for the job, you have to understand how stuff works. You don't know if you're using the right tool if you don't know all of the intricacies of that tool and the environment you're trying to put the tool into. So a few final thoughts, just to kind of wrap everything up. Most of you probably learned something about textiles in the span of this talk. And if you are as big a textile nerd as me and you didn't learn something about textiles, you probably saw them in a new light, because even as much as I have been sewing and crocheting since I was a child, I never thought about them in terms of computer security until this spring. And that's really the idea here, that no matter what the field is, there's something that you can learn from it, and there's something that you can learn from the people in that field. A lot of the people that are new to security have experience somewhere else in the world. And so take the time to stop and learn something from their experience, because there's a lot of fundamental truths that you can learn even from a completely different field. So that is all I have for you today. As mentioned before, I set up a Q&A session. The link should be in the chat. If you have any other questions for me, you can hit me up on Twitter at TindrisGrove or Amanda@tindrisgrove.com. That is all I have for you today. Thank you ever so much for listening.